Hi, I'm an old guy and I do maths. We have a fairly convoluted problem here today. I wouldn't say that it's difficult, but it is convoluted. And it's essentially a geometry problem that involves a little bit of algebra, or a small algebra problem that involves some geometry. Depends on your outlook. So the story is this. A triangular prism has a base that is 5x by 12x by 13x, the three sides of the triangle. And it is h units tall. Now we don't know what h is, we don't know what x is. What we do know is that all of its edges add up to 180 units, whatever these might be. And we're asked to find h in terms of x. We're asked to find what the volume equals in terms of x. So that's basically write a formula for the volume using only x as a pronumeral, so no h. And then we're asked to test that by inserting 3 into the formula and finding out what the volume is. And once we get that answer, we have to explain what that means. So, let's get started. Let's draw this thing. So, a live drawing event. This may or may not be pretty. So, I'll try my best with the artwork. So, here goes. Now, we'll call this 5x, the short side, and this 12x, and this is not to scale at all, and this 13x. And what happens is this thing forms a triangular prism, sort of like this. And this and this are the same size, they're the same triangle, and the height of this thing is h. Okay, first question. Find h in terms of x. Now, the only way that we can do this is to make use of this piece of information here, that all of the edges add up to 180. Now, all of the edges, what does that mean? That means that we don't just have one edge, which is h in length. We have 3. 1, 2, 3 of these. That this is 5x as well, that this is 12x, and that this is 13x. And so, that plus 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 that add up to 180. So, let's get to work. So there's 3 lots of h, that's 3h, plus 5 and 5 is 10, 10x, 12 and 12 is 24, 13 and 13 is 26, and that all adds to 180. So, some tidying up. 3h plus 24 and 26, that's 50, and 10 is 60. X equals 180. So you can see that this is just basic linear algebra. There's nothing really tricky going on here. But the key is to understanding what an edge is, of course, which is the edges, if you will, of this this shape, and to making sure that you get this part of it right. Because once you get this part of it right, it's just a matter of counting and then some very simple algebra. So 3h is equal to 180 minus 60x. Now, if you don't understand this step, what I've done is I've subtracted 60 from both sides, 60x from both sides. That gets rid of this, and it creates a negative 60x over here. Now, we want to know what h is equal to. We know what 3h is equal to. So if we divide this by 3, we get our first answer, h, is equal to that divided by 3, which is 60, that divided by 3, which is 20x. That is our expression for h in terms of x. Now, the volume equals what in terms of x? So, volume. Well, volume is the base times the height of this. So the area of the base times the height. And we need to take account of some interesting features here. One of which is the nature of this triangle. So, just take that page off to the side and I'll be referring back to that. We have a triangle, and I'm deliberately going to draw it sort of sideways so it's a little bit harder to see. We have a triangle that is 5x, 12x, and 13x. Now, some of you will notice that this is a Pythagorean triple, and that 5 squared plus 12 squared equals 13 squared. So that means that we have 12x along here, 5x here, this is a right angle, and 13x here. Now, what is the significance of that? Well, what we have to do, I remind you, is we have to find the area of this base. And the area of a triangle is base times height over 2, or a half base times height. So, what is the base? What is the height? We can't use 13. Well, we could use part of it and maybe work out a distance here, but no, you don't want to be doing that. The simple thing is to say that 12 is the base and 5 is the height. So if I turn it that way, you can see that. Or alternatively, and it doesn't matter at all, you can say that 5 is the base and 12 is the height. Whatever, this is what it is. So the area of this is equal to 12x times 5x over 2. Now, 12 5s are 60. 60 divided by 2 is 30. And x times x is x squared. Okay. We have the area of the base. Now, what we're going to do is we're going to take the height of this thing, written in terms of x, and multiply it by that. So, here goes. 30x squared into 60 minus 20x. That is what the volume is equal to. That is the base, the area of the base, times the height. But we're not finished. There is much more fiddling about to do, because in this form it doesn't make it easy for us to answer question 3 and question 4. So what I'm going to do is I'm going to expand this and then I'm going to refactorize it. So 30 times 60 is 1,800 x squared, and 30 times 20 is 600, and that is x cubed, and that is negative. So we have that. Volume is equal to that. That equals that. Now, I'm going to refactorize this, and you'll see why I've gone from here to here and back in a moment. What we do is we take out the highest common factor of these things, which is 600 x squared. And 600x squared times 3 will give us this. and to get 600x cubed, we multiply this by x, and so that is the fully factorized form in terms of x of the volume of this shape. Right, we're on to question 3. Now question 3, as you might recall, having found what the volume equals in terms of x, if x equals 3, what is the volume? Well, all we have to do is put 3 into this. So x equals 3, so that is 600 times 3 squared, which is 9. We'll worry about that later. And 3 minus 3. Now, we don't need to worry about this at all, because 3 minus 3 is equal to 0. And so if we have 600 times 9 times 0, the answer is 0. So when we put 3 into this equation, the volume is 0, which means that it has no volume, which means that it is presumably some sort of two-dimensional shape or something. It might have area, but it does not have volume. Well, yes, I guess that's an end in itself, but there's something else to say, and that is that had we put a number smaller than 3 into this thing would have had volume. So, for instance, just to take a very simple example, 600 times 1 squared, so if we made x equal 1, times 3 minus 1, we would have had a volume. It would be 600 times 2, which would be 1200 units cubed. So what we know in terms of the domain of this function, and I'm assuming that that's what the question was getting at, the domain of this function has an upper limit of something just below 3. So x has to be less than 3. So let's just write that there. X needs to be less than 3 in order for this equation to be a number greater than 0. So, for instance, if you put a negative number in here, this number will get bigger. It's bigger than 0. It will multiply up. The same is kind of true here, because a negative number squared will be a positive number. Let me show you. I'm going to put 4 into this. Negative 4, I beg your pardon. I am putting negative 4 into this. So x equals negative 4. That is 600 times 4 squared, negative 4 squared. Now that is going to be 16, so 16 times 6. We don't need to worry about that. We just know that it's positive. Times 3 minus negative 4. So what we have is we have 600 times 16, all positive, times 3 minus negative 4, 7. And that equals positive units cubed. So we have an upper limit on the domain of this function of x being less than 3. And I think that that's what the questioner was getting at. Anyway, thank you very much for watching this. It was convoluted. I hope that I've explained all the answers. If you found it useful, please like and subscribe, and I will see you next time. Bye.